So good afternoon, everyone. So this afternoon, I'm going to cover the PowerTag offer, just educating everyone a bit on what is PowerTag and how it actually empowering energy efficiency, and also at the same time how we use power looping. So now we call this as a load monitoring. Let's look at PowerTag itself. Why PowerTag? So as you know that at the load level, all right, so today we have a solution, all right, to monitor at the final distribution load level. So when we say load level, means that we are talking about all those very small ampere, like from maybe 16 amps or even less than that, all the way to 63 amps. And these are normally using in those things like socket loads that you have, like you are powering up a refrigeration, air cons, lightings. So sometimes you may want to really understand a bit how much energy you consume for lighting loads, socket loads, really looking at the final distribution side. Why PowerTag? If you look at energy, of course, we use PowerTag when we are interested in terms of doing energy cost allocations. So we wanted to understand a bit based on one floor area, how much energy costs consume and how we can allocate the cost to a different department, that consume energies. It's also ISO 50001 enabler. All right. So if you understand a bit on ISO 50001, this is one of the important part because it can go all the way dive down into individual load monitoring to understand on your consumption patterns on the load side, how you consume your energy. It also has compliance with a new local standard. So there's a lot of metering today in the market, but definitely there are metering related to local standard, and especially when they say local, well, it still fall under the IEC. All right. So the only thing is a compliance. Then of course we can actually monitor the consumption by each usage or by zone. So it may, for example, if you're looking in the office area, you may even talking about how much energy consumed in the area, the IT rooms, in the pantries, in the walkway, all those. So we are able to monitor to those kind of final distribution loads, all right, to those kind of extents. Of course, when you come to peace of mind, whenever there's any overloading on the network, especially on the final distribution, whenever there's any voltage loss, they trigger alarms. All right. So basically, PowerTag will be able to trigger alarms to notify you that there's a voltage loss or there's an overloaded. All right, that caused the breaker to trip. Then, of course, PowerTag itself is part of the EcoStruxure platform. All right, to manage energy efficiency, energy consumption, and to reduce any downtime impact. So that is the solution today. If you're looking into final load monitoring, PowerTag is a good solution. Let's go deep into it, all right, to the next few slides, then you understand more about this. So where do we normally use PowerTag? As you know, in the sub-switch board level, where there's a MCCB, where you see this is a MCCB, okay? We can use a MCCB with a PowerTag called NSS PowerTag, okay, where we can attach to the bottom of the MCCB. Then we can do metering. Means that every current, any power that drive through the MCCB will be monitored, how much energy consumed. At the same time, if you look at the final distribution, especially when you look into MCB level, whether single pole, three pole, double pole, you also can put it at this level, which monitoring the incoming as well as the load level where we are monitoring the outgoing. Okay. PowerTag itself can monitor, is compliant to IEC 61557-2 standard. This is one of the metering standards. And of course, it can monitor energy data, real-time information related to all the voltages information, current information, power information, all right? And then, of course, they trigger alarms when there's a voltage loss. Okay, so what is the benefit for PowerTag? If you look at the architecture of this PowerTag, first of all, is wireless. Between the PowerTag and the data concentrators, is actually wireless. It's go by Zigbee communications. So you don't really have a lot of messy cable that is, going around the panel itself, just for metering communications. But from the gateway out, it could be a wire, or it could be just pushing data. So there's two solutions that is moving out to the connecting to the system platforms. So PowerTag as an energy sensor is actually is by itself is a wireless communications. Secondly, there were not a very significant impact on the footprint. Why? Because the sensor itself is very small. It just sit on top or below the breakers. When I say breaker, it means the MCB. So you don't really allocate a lot of space, right? And then basically when you sit on the top or the bottom of the MCB, you just run a cable through it. That's all. And then you do metering at the MCB level, whether it's incoming or outgoing to the right. So there will not be much impact because it's not something that you need to allocate space for, a lot of space for the PowerTag to be stored inside the panels. Scalable. So today you may consider just having just a handful of PowerTag just for some critical. In the future, if you want to expand to add sensor to monitoring more load, it can scale up quite easily. All right. So there are no limitation about number of PowerTag in one panel, right? But there are limitation of number of PowerTag that is linked to one data concentrator. It's either PowerTag that 20 PowerTag to one data concentrators, or 100 PowerTag to one data concentrator. There are limitations on that, all right? But how many PowerTag should be designed in one panel? There are no limitations. It's a very easy to install and commission, why? Because a lot of all the step of installing, most of the CT and the concentrators, they detect each other's, all right? They sense each other, and then after that, they just connect together. Then the next step to do is to provide naming to those sensors. What are the loads that you're monitoring? Why is it easy to install? You look at the way that it's being installed on a single pole neutral bottom. That is how you put a PowerTag, connect to the bottom of the MCB and run two cables and then terminate the two cables. If you look at for the 3-pole, all right, that is how it's being installed. Also at the bottom. Why we put it at the bottom? Because we are monitoring the load, so we put it at the bottom, right? So if you're monitoring the network, then you put it at the top, which is more on the income side. So as I said earlier, there wasn't a lot of footprint required because basically you just sit on top the MCB or sit below the MCB. Anyway, you still need the 3 wire to go through the CTs, the sensors that go to the terminal block the terminals of the MCBs. We also have another set of PowerTag that is work on MCCB. Okay, so we call it NSX PowerTag. It's actually connected to the bottom or right of the MCCB, and then the cable just terminate the top and the bottom. Okay, and then you are doing metering on your MCCB by wireless communications. It also works on the companion INS and INV as well, right? The same methodology, put it at the bottom. Then you connect it, and then you just terminate the cables to the 8 terminals. So it is very easy to install. If you wanted to enable metering due to space constraints, where you cannot mount standalone meters or put additional CTs on the cables. This could be a very neat solution, all right, for your customers. The next thing is that PowerTag also compatible with PC's range, like GV2, GV3, GV5, GV6, okay? So 3 type of breakers that you can do it, all right? First is the MCB level, which is up to 63 amps. MCCB level, all right? Or the INS-INV level, which is the earlier that you saw, and also the TGV range. So when you look at why we do monitoring, all right? So when you connect a breakers down, basically the current flow through the phase to neutral, okay? Then you get energized when you turn on the breakers, and then you read voltage, currents, power, energy readings directly from the CT sensors. Whenever there's a breaker trip, means a voltage loss, you will trigger an alarm, and the alarm was sent to a systems or sent to the software or to some of the car platform to notify the operators. When you come into the design, basically the power tags are sitting, as I mentioned, the NSX power tag was sitting with an MCCB. Then we have a power tag, okay, sitting at, and then of course this power tag, smaller power tag at the bottom here is to monitoring the load. So you sit at the bottom of the MCCB. That is when you're monitoring the load. When you're on the breaker, the current flow through directly the load you're monitoring was the consumptions. Power tag also has some IOs controls for control purposes. Like you wanted to monitor the breaker status here and there, you can actually bring these IOs into it as well, into the panels. But the last but not least, PowerTag link is what I mentioned earlier. There's no limitation on number of PowerTag inside one panel, but there are limitation of PowerTag link to the PowerTag link. This is the data concentrators, all right? We only have 2 type of data concentrators. One that can connect up to 20 PowerTag. So when you look at one of these, is considered 1 PowerTag, 2 PowerTag, 3 PowerTag, okay? So we can go up to 20 with one single gateway, which is a PowerTag link. Or we can go up to 100 wireless sensor. Means that instead of, because of a panel is you only have a couple of PowerTag, it doesn't make sense for you to get a 100 wireless sensors data concentrator. You basically will go for the 20. But of course, you have if you have rooms in future to expand your number of PowerTag for more load monitoring, then you may want to consider to get 100 PowerTag sensors, the data concentrator. So in the future, you can just add on PowerTags to the board and then link to this sensor without having to change this PowerTag link. Okay. Then of course, when you have this, eventually you will link by communications by Ethernet directly to a system platform or to the cloud platforms. You come to commissioning, it's very easy to commission, all right? So PowerTag itself, they detect all the different concentrator that's near to it by wireless communication ZigBee, all right? Whenever they auto discover, they will just recognize that this PowerTag is linked to these particular sensors. These are data concentrator. There are 2 ways of locating. As you can see, whenever there's a communication going on, detecting the red LED, the green LED light will start to blink. Means that they are actually detecting the data concentrator. Once it's being detected, it will just auto discover. All right. Then of course, after you have to configure it. To configure it, you need to provide a name to the PowerTag. All right. So what is the name? Like what are the kind of loads that your PowerTag is monitoring? You need to give a name so that we can recognize that this particular PowerTag is monitoring small little motors. All right. So there must be a name given to it. All this configuration has to be done in the data concentrator, the PowerTag link, which inside this PowerTag link is basically a web server where you can do all the connectivity with all the PowerTag sensors. All right, and then you are also have HTML pages that you can read all the data directly from the sensors. Okay, so before you can export the data out to a system platforms. So the PowerTag link is not just a gateway, but it serves as have a web server functionality where you can read all these PowerTag connected to these particular gateways. So these are the range of PowerTag we have, all right, up to 63 amps. Okay, some are basically directly connected to the 99 MCBs or 89 MCBs. And some, especially for all those with a neutral, you will have two pieces, one connected and the other one is just hanging along the cable. And then we have a PowerTag Flex, which means that you're flexible for any of the devices, whether is it a Schneider breakers or competitor breakers. If you want to do metering on those breakers, you can use the flex type, all right, which means that basically a cable that goes to the same terminal of the 3-pole or the single pole MCBs, and then the sensors are hanging along the cable, right? So there are offers that are for Schneider breakers. There are offers like flex type are basically a very open offers that can use in any brands of breakers that the market has, right? So that's why you call it flex, because you can use on the competitor MCB. The NSX PowerTag is only work on Schneider compact NSX breakers. Okay, so it will not work in any of the competitor breakers. But for the PowerTag, the earlier one, only the flex will work on competitors, but the other two will be mainly Schneider MCBs. The last thing is more on the PowerTag. Okay, so as I mentioned, the PowerTag we have two kinds. One is basically the gateway that can link up to 20 PowerTag sensors, or a gateway that can go up to 100. We only have these two models available today. So just to let you know, people who are familiar with this Smart Link, we do have Smart Link SID. Okay, so basically this model has been the MWA, this model has been discontinued and replaced by this model, which is shown here on the left. Okay, so but these offers are still available today. Okay, the Smart Link SID. So there are two types. One is a SIB, one is a SID. Okay. So how we position against the breakers today, all right? So if you look at all the MCB that go up to 63 amps, will be using the PowerTag start with M, P, and F. Okay, so up to 63 amps. So when you go into MCCB, that within the range of 250 to 630 amps, then you can use the NSX PowerTag. If you attended my roadmap call last week, we are launching two offers, which is called PowerTag F160, that cover the gap of anything in between 63 and 160 to 160 amps will be covered by this new offer called PowerTag Flex 160. All right, and then we also have a PowerTag groups that go up all the way to above 1,000 amps. Okay. So we are basically, if you look at the range, the offer that we have today, we are actually covering quite a wide range of breakers from MCCB all the way to MCB, whether is it 2,000 amps all the way to anything below even 63 amps. Okay, so that is how you're going to position what are the right fit on the PowerTag for the different type of breakers. So So where do we sell our PowerTag? I think these are something very interesting because we basically sell PowerTag everywhere, buildings, industry, anywhere that people wanted to monitor their loads monitoring, all right, loads, which is less than 63 amps at the MCB level or sometime at the subswitch board level. You can consider using PowerTag as a solution. If wireless is preferred, it's no objection. All right, wireless communication, there's no objection. It could be a very neat design. And then of course, the segment that we cover today, basically, as you see, is basically everywhere. All right, it's just a matter of whether the type of information required. Is this purely just for energy efficiency, energy management? PowerTag could be a good solution that you can go all the way down to do load monitoring. But of course, if you're in certain critical buildings or segments where power quality is required, then of course PowerTag are just monitoring the non-critical loads. Then those standalone metering with power quality functionality will be monitoring all the electrical infrastructure and critical loads. So we have basically a lot of success stories around the world with PowerTag today. Of course, if you need any of these success story for any particular segment, please reach out to your EcoXpert salespeople in the countries. All right, they will be the one that is going to get this information for you. All right. So of course, PowerTag as we call it a connectable product. All right. Under EcoStruxure Power, we are able to connect PowerTag into PME as well, Power Monitoring Expert, Power SCADA Operations, where we are, as I said, this is basically doing load monitoring, where we are looking into the critical loads in the final distribution side. Okay, so we are able to look at things in like a single line drawings and look at the consumption pattern. So again, look at in a pie chart way, like to understand, when the energy consumed in an area, how much is being consumed by lighting loads, how much is being aircon loads, or we can actually monitor those using PowerTag solutions. So we also have a lot of videos. All right, so videos are found in our Schneider portal. Some videos can be found in the YouTube that to teach you how to install PowerTag. All right, so how you design a panel, how do you install a PowerTag properly, how you commission a PowerTag. All these is documented in the video. So you can actually leverage on this video to do self-learning, right? So it's not a very complex offer. It's a very simple offer, but you still need to know a proper way of installing, what is the best practice, so that you not get yourself into like, safety issues. All right. So it's good to, if you're really interested in this offer, please run through some of these videos and really, if you're doing installing PowerTag in a distribution board, what should be the best practice to install it, without having much disruption, and also causing any safety or injuries to any of these technicians that is putting a PowerTag into the box. So it's really good to learn how to do it, and then we have all these videos that is helping to teach you, to provide you all these guidance.